Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. So first of all we are going to find the solution, then we are going to do some coding work. And also the other goal is to see how to solve this problem in proper way in a real interview. So let's get started. So remember, in the real interview, the first step is always try to understand the problem. If there's anything unclear, please bring up the question, and also at the same time think about some edge cases. So let's take a look. Walls and walls and gates. So you're given an m by n grade rooms initialized with these three possible values. -1 is a wall or an obstacle, 0 is a gate, and infinity means an empty room. So we use so this is max positive int for int 32 to represent the infinity, as you may assume that the distance to the gate is less than this, which is integer max value. So fill each empty room with the distance to its nearest gate. So if it is impossible to reach a gate, it should be filled with infinity. So let's take a look at this example. We have something like this, and we have the room. So this is the input defined as a 2D array. So the output is something like this, because this graph shows us the shortest distance for the nearest gate. So so I think, having said that, we are pretty much clear about the problem itself. Let's see some constraints. So it says that m is equal to rooms.length, n is so m is it is an m by n matrix, and m and n is between 1 to 250, so it is not empty for sure. So room ij is between -1 or 0 or the infinity. Alright, so I think we should be good to go about this. So I don't think I have any edge case, so let's step into the next part, which is about finding solution. So this is a pretty standard BFS question. So we initially we have a queue, and we insert all the gate position into it, and in each step we try to extend to the 4 directions and also record the distance. So the runtime is going to be O m by n. So let's see, the next step is about doing some coding work. So for coding, we care about the correctness of the code, the readability of the code, and of course, don't be too slow. So let's give it a shot by doing some coding work. So first of all, we have a queue. Let's define something like position. So let's define something, let's call it just a private class position. Okay, so we have three things. The first one is the row number, and the second one is the column number, and the third one is the distance. So the distance means the shortest distance to the nearest gate. So let's give it a constructor. So position row con into distance, row this dot call is equal to call this dot distance is equal to a distance. Alright, so that's the definition of the position. So the queue contains all the positions. So it will be something like queue e is equal to new let's say linked list as and then we are going to go through the input array. So let's see, let's say int row is equal to rooms dot length, and call is equal to row 0 dot length. So we are going to have I is equal to 0, I smaller than row, the plus plus I, j is equal to 0, and j is smaller than the column, plus j. So if it is gate, so if rooms ij is equal to let's say, so 0 is gate. Okay, if it is 0, then we are going to put q dot add the new position. This is I, j, and 0. Alright, so after that, after initializing the queue, we will first see if there is any gate actually. So if there's no gate, then we don't need to do anything. So if q dot is empty, then we are just going to return. Otherwise, we need to do the BFS on top of it. So it'd be something like, well, q dot is empty. Our q is not empty, then we are going to try to extend in the 4 directions. So int size is equal to q dot size int iter as 0, iter is smaller than the size, and plus iter. So we will have the position p as equal to q dot pool, and we will try to extend in the 4 directions. So let's say we define a helper function. Let's call it extend. So we will extend the position. Let's say p dot row, and p dot column, and then the rooms. Okay. Let's define a helper function here. So let's call it extend, and of course we need to have the queue passed into it. So this is void extend. So extend, essentially it is going to extend in the 4 directions. So this is column, and this is rooms, and this is the queue. Yep, so we will extend it, and then alright, so this one I would say we extract the position, and then we are going to need to set rooms p dot row and p dot call as equal to p dot distance. Finally, we're just going to return. So it is void as a return value, so we don't need to return anything. So every time we just get the first element from the queue and set the distance from the room, and then try to extend it. Alright, so I think that should be it. Let's try to implement this helper function. So I would say if row so if row is larger than 0, and rooms so 0 minus 1 is obstacle. So if rooms I would say call row and the column. So essentially I need to make sure it is not a gate, it is not an obstacle, and also it is not so it's not a gate, not an obstacle, and we haven't visited yet. So let's see if also I think we also need to pass in the distance. So the distance. So let's see. So if it is how to see if it is not visited. So if it is equal to a infinite, so integer dot max value. So if it is equal to this, that means it is an empty room. So if it is an empty room and we can extend to it, then we are going to have q dot add a new position. This is row -1, this is column, and also this is the distance +1. So also we are going to do similar things. Let's say row is smaller than rooms dot length -1, and rooms, this is row +1, column is equal to integer dot max value. Then we are going to have q dot add the new position. This is row +1, column, and the distance +1. So if column is larger than 0, then and rooms row, this is col -1, this is row col -1 is equal to integer dot max value. Then we are going to have q dot add the new position. This is row column -1, and this is the distance +1. And also we are going to see the left part. So if col is smaller than rooms dot room 0 dot length -1, and rooms row and column +1 is equal to the integer dot max value. Then we are going to have q dot add a new position, row column +1, and this is distance +1. Okay, so I think we should be mostly in good shape. So the next part is about testing. So for testing, we care about first of all, we need to do some sanity check to check about the logic of the code, and also explain how this piece of code is going to work, some communication with your interviewer, and also after that we can indicate what other input test cases we want to set up to have good enough test coverage. So let's see, wall and gates. It's q initialize as empty, and then we have the row and column. So for the example, we are going to put those two positions with distance at 0 into the rooms. And so it is not empty, so it is not going to return. So while the queue is not empty, so we have the first layer, the size of the first layer, which is 2, the 2 gates populated, and so rooms is equal to distance is 10, this yep. So we are going to have the distance, so every time we pull it, we set the distance for it. Yeah, so when we try to extend, we see that so we try to extend, we extend in the 4 different directions. So for this one, we see if the row is larger than 0, then you're going to see it should be like, we see the upper side. So this is upper side, yep. And this is about the lower side, so row +1. Okay, this is a column at the left side, my row column -1. This is the right side, which is column +1. Alright, so I think it should be good. Let's give it a shot. Alright, so it's wrong answer. It's weird. So output is 4 minus 1, 4 minus 1, 0, 1. And how could that be? Oh, that's because we already set it here. Okay, so like after we set this and we set it again. Yeah, so I would say if integer, like for this, we add the first two position at the very beginning. If this position is reached out by this, I don't think it should be possible. How could that be possible? I have already, so q dot add, so after we finish this, okay, so it is a sequence when we set the distance actually. So if we set the distance, so if we don't set the distance here, but instead we are going to set it here. Sure. So let's say, so this one, let's say set rooms, row -1. This is a column as distance +1. Similarly, we're going to have the copies here. So +1 row column -1, this column +1. So let's say for this, every time when we try to extend, we already set the distance. So like for this one, the first layer is this, so we insert those three things into the queue, and then we set it. And next time we are going to insert those three things in the queue, and we are going to set the distance at that time. So, and this one we set the distance. Okay, so it's more about when we set the distance. If we set the distance when we try to pop the thing from the queue, I think it's too late. So like for this one, for the third layer, 1 2 3, we have those things visited. So for this, we have those stuff visited. Because for the third, if we just set the position in the next layer, so it's like we set the position in the next layer when we pop it. So let's say in the third layer we are trying to set the distance for 2, so that will be too late and it's going to cause some issue. So instead we should set the distance as earlier as possible. Okay, so let's give the submission. Okay, so now everything looks good, and we should be good in shape about this question. So if you have any question about the solution or about the code, whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.